welcome aboard. I'm your host, Captain Paul Havis, and we have a very interesting and unique documentary in store for you today on building and test flying the 727 and 747 aircraft. I'm speaking to you live now from the Newark International Airport in Newark, New Jersey. In fact, both of these airplanes you're going to be seeing in our documentary have significantly altered our air transportation industry as we know it.
The 727 is Boeing's three-engine narrow-bodied airliner. It was designed and built in the early 1960s to enable airlines to serve the smaller airports of the world economically. Although it can operate routinely from a 5,000-foot runway, it still has the comfort, speed, and range that passengers expect from a jet airliner. Consequently, the 727 could visit airports that had never before had jet service. For both the remote and big city airports of the world, though, the 727 became the dominant airliner and the one of choice for the airlines. It's no wonder, then, that it also became the best-selling jet airliner in the history of commercial aviation in the 1970s, with over 2,000 727s eventually being built. Although it's no longer in production, the 727 will fly well into the next century. Its big brother, the 747, is nicknamed the Jumbo Jet, and it's a four-engine wide-body long-range aircraft. With a passenger capacity of over 500 people, this one airplane is credited with lowering the cost of long-distance air transportation by being so economical to fly. Although it looks imposing, the 747 is actually a very nice airplane to pilot, and with ample area to move around in, it's the favorite way to fly for the vast majority of passengers. It's also, statistically, the most widely recognized commercial airliner in the history of world aviation.
The program you're about to see was edited by us after viewing literally hundreds of hours of test footage and promotional movies that are stored in the Boeing film archives in Seattle, Washington. Keep in mind that at least as the test footage is concerned, it was really intended to be viewed by the engineers and test pilots of Boeing and not the general public. So for now, let's set our watches back to 1963. The prototype for the 727 is about to take off for the first time.
It's February 9, 1963 to be exact, and airplane number 1 is ready for its first flight at Boeing's Renton Airport in Washington State. From today's date, that left less than 11 months to meet the December certification deadline specified by the two launch customers, United and Eastern Airlines. Heading up the test pilot team was Lew Wallach, Jr. Co-pilot Dick Loesch and flight engineer Marvin Schellenberger stood by while the logbook was ceremoniously signed by Captain Wallach. Meanwhile, final preparations are made for the flight that will ultimately end in the 727 gaining full FAA certification. The last pre-flight check is to exercise the hydraulic-powered flight controls one final time to confirm their proper operation. With all three engines started, the ground crew clears the last of the support equipment away, and Captain Wallach advances the thrust levers and taxis out. The weather was cooperating too. It was an unseasonably clear day with light winds from the north. This was essential, since all departures had to be on the north runway, out over the lake and away from populated areas, just in case. Finally, all eyes focus on the 727 as it starts its takeoff roll. Weighing in at about 130,000 pounds, the acceleration is brisk, and the ground run is barely over 3,000 feet, remarkable for a jet airliner. Still, the unexpected happens, though, when the center engine surges just after liftoff. The crew reduces power on it somewhat, and the vibration mysteriously terminates. Yet another problem was discovered when the wing leading edge flaps could not be retracted. Apparently, the hydraulic actuators for them were too small for the airloads and would have to be redesigned. Nevertheless, 2 hours and 6 minutes were spent evaluating the handling of the 727, and for this, it got an enthusiastic thumbs up from the crew. The first landing of the prototype was at a different airport, Payne Field in Everett, Washington. Approach speed was 110 knots, confirmed earlier in the flight by stalling the airplane, so they knew exactly just how slow it could fly. The flaps were also extended to their maximum value of 40 degrees. After touchdown, Captain Wallach applied moderate braking, while the engines were only placed in idle reverse thrust. Amazingly, even on their first landing, the crew was able to stop the 727 in only 2,000 feet of ground roll. The next day at Everett, before the real work began, ground tests were completed on the 8 tons of onboard equipment which were required for the flight tests. slow-speed flight was the first area examined on the next few tests. 750 individual perimeters were recorded in flight for later analysis by ground-based computers. 16 hours and 21 minutes were spent testing the aircraft at slow speed. This included numerous full stalls. With the aircraft stabilized at its minimum flying speed, the pilot would apply consistent back pressure, forcing the nose to an even higher angle of attack. Prior to stall, the aircraft would buffet and the nose would pitch down itself, effectively recovering from the stall on its own. The airplane could quickly be returned to level flight. With the slow-speed testing complete, the 727 entered the high-speed phase of testing, specifically how turbulence might affect high-speed flight. The right-hand elevator had a small vane attached to it to induce flutter to the tail. Flutter is a potentially destructive force at high speed, so it was imperative to see how well the 727 naturally dampened out these vibrations. The right-hand wingtip had a similar vane attached also, but the wing itself moved only very slightly. The aircraft was also flown in a dive to airspeeds of 460 knots and Mach 0.96, clearing it with regard to flutter and high-speed flight. The wing was also a radical new design and received much testing. The tried-and-true method of attaching small tufts of yarn to the wing made it possible to visually see the airflow. With the spoilers up, the airflow took on a different look than before, as evidenced by the tufts behind the spoiler. Rolling maneuvers were initiated to record photographically the effects on the airflow. The arrow points to the area of tufts that delineate the shock wave caused by the wing as it approaches the speed of sound. Sections of the lower wing were tufted also to study airflow around the flap tracks. Other sections of the aircraft of interest to the engineers were also tufted and photographed at varying airspeeds. In all these cases, the airflow exhibited by the tuft patterns was smooth and streamlined. This proved the 727 had good airflow characteristics. Back at the airport, testing continued on takeoffs and landings. A normal takeoff, weighing 145,000 pounds, yielded this departure. For the high rotation test, the test pilot would accelerate to liftoff speed and pull back harder than normal on the stick. The weight was also 145,000 pounds for comparison purposes. This test was to prove that the aircraft could still continue flying after such an abusive pilot input was made. The over-rotation test was even more dramatic. The test pilot held the stick full up from the start of the takeoff roll. This causes the nose to lift prematurely and the tail skid to strike the runway surface. Again, it's all to prove the 727 can definitely continue flying if it happens for real. The refused takeoff tests were conducted at Edwards Air Force Base in California. These tests were made at the full range of permissible takeoff weights for the 727 and every possible flap setting. The test pilots accelerated the aircraft normally to its liftoff speed, today calculated at 124 knots. At that point, instead of lifting off, the throttles were closed and the wheel brakes were selected to maximum. The engine thrust reversers were not allowed to be used. The distance it would take to stop the aircraft would be recorded and used later by the airlines. Maximum effort landings using brakes and thrust reversers were also demonstrated. In this landing, the 727 weighed 133,000 pounds. Amazingly, the ground roll was a mere 1,700 feet of runway. Landings were also made on wet runways too, to test the effectiveness of the new anti-skid system developed for the wheel brakes. Even though the brakes were applied to maximum by the pilot, and even though the runway was wet, no skidding occurred. These tests confirmed the effectiveness of anti-skid on wet runways and exemplified the typical 500-foot difference between dry and wet runway ground roll distances. The 727 was flown to Great Falls, Montana for crosswind landing tests. This part of the country notoriously had strong, steady winds, which proved perfect for the test series. The gross weight for this landing was 132,000 pounds at a flap setting of 30 degrees. These tests eventually certified the 727 for landings in direct crosswinds of up to 30 knots. The 727 was flown from Renton to Seattle, where a special fixture had been constructed to accomplish strain gauge calibration. 1 month was required to install this instrumentation for the flight load survey. The in-flight load-bearing data was then used as a comparison for the completely separate ground testing of two 727 airframes. One would prove the static structural strength, and the other would test the fatigue life of the airframe. With the installation of test equipment complete, the first instrumented takeoff was made from Boeing Field in June of 1963. The loads experienced in both low and high-speed maneuvers, as well as the loads induced from turbulent air, were measured and recorded in flight by a staff of engineers assigned to the project. Meanwhile, back in the cockpit, testing continued on the new autopilot Boeing had installed in the 727. In this footage, the autopilot is engaged about here to test its ability to fly a low weather minimums approach in turbulent air. The crosswind reported was about approximately 20 knots, and it had little effect on the autopilot's control of the aircraft. Certification of the autopilot in the 727 initially was made to the minimum values of 200 feet above touchdown, after which manual control for the landing was required. Additional equipment later enabled the 727 to fly itself to 100 feet before the pilot had to take over. The test pilots, of course, allowed the autopilot to take the aircraft down to less than 100 feet before disconnecting it. The total runway used, of less than 3,500 feet, is representative of that for an actual low weather minimums approach and landing in airline use. Here, Boeing designed a unique way to test the 727's water spray pattern. With normal tires, the aircraft is accelerated to ramps containing 1/2 inch of standing water. Different combinations of speed, weight, and flap setting revealed that the spray from the aircraft's nose wheel had the nasty habit of drenching the two outboard engines. When viewed from the front, the spray effect from the nose wheel tires was even more noticeable. These tires had smooth sidewalls. Consequently, the answer was to deflect the water spray further away by installing a different type of nose wheel tire. A special rib tire was developed called a chine tire. It proved successful in deflecting most of the water away from the engines. Water traps installed on the engines themselves proved without a doubt that the new tire worked as advertised. The head-on view shows dramatically the improved spray pattern achieved by these tires. With most of the testing complete, it was time to show off its new airplane on a world tour. 187 flights were made totaling 256 flight hours and covering 122,230 statute miles. The FAA was aboard for the world tour as well, because the trip would also be the function and reliability testing required for certification. Wherever the aircraft stopped, invited officials swarmed over the 727 in anticipation. Here was a jet airliner that could depart from a small airport and fly to a destination over 1,500 miles away. It was widely received and Boeing offered demonstration flights to airline and government personnel to show off its 727. The unique rear-mounted engines resulted in a very quiet cabin, which impressed countless guests. The World Tour segment to South America took advantage of La Paz, Bolivia, the highest airport in the world, with an elevation of 13,500 feet. Here, testing proved the 727's ability to safely operate from extremely high altitude airports. Effectively, the test program was now complete. On Christmas Eve, December 24, 1963, type certification for the 727 was received by Torrey Gamlin, Vice President of Commercial Airplane Division, from Charles R. Hawks of the FAA. In just 10.5 months, the Boeing company met the challenge of delivering a certified airplane to the two original contractors, Eastern and United Airlines. This piece of paper really belonged to the thousands of people who worked so hard on the project, known as the 727. February 1st, 1964 dawned beautifully clear at San Francisco and heralded the start of commercial service for the 727. In the pre-dawn twilight, 105 passengers walked down the jetway and into the sparkling new aircraft. What they didn't know, and neither did the crew, was that they would be flying into history on their flight that morning. The 727 would prove itself the most popular aircraft of its era. Over 2,000 would eventually be built, bringing air transportation to the most remote and unimproved airports in the world. So the flight really wasn't that special. It would be repeated millions of times. What was special was the design, known forevermore as the Boeing 727. Now that the 727 was certified, Boeing had a difficult time keeping up with demand because it wasn't just a matter of making a few prototypes anymore. Now it seemed like every airline wanted one. They filled Boeing's order books just about to the brim. Sometimes the waiting line was over a year to get this particular aircraft. So Boeing reverted to doing what it does best, and they actually mass-produced the 727. Putting an airline 727 together involved over 1 million parts, some of which were pre-assembled into units called sections. These sections can be quite large, but the one thing they all had in common was an individual part number. This identifies the section and helps speed the assembly process along. Although sections may look identical, they may carry a different number because the purchasing airline chose to have some customized changes made to it. Even carpeting, which is cut precisely to specifications, carried a part number. And although interior walls start as silkscreen vinyl, the batch is always compared to a master reference sheet to produce consistent results time after time, so a customer's entire fleet will precisely match. Since the average 727 contains over 45 miles of wire, Boeing put a lot of thought into keeping this potentially confusing aspect of construction foolproof. Each inch of wire used in the aircraft was fully accounted for. Special machines, like these, were devised to cut wire to the desired length and even imprint it with a part number that identified the exact position in the aircraft it was meant for. Pre-fitted with equipment as much as possible, these major sections are now ready to be joined. First, the tail section, with its unusual ducting for the number 2 engine visible, is lowered into position to be joined to the aft body section. Mounted in a special tool to ensure proper alignment, the sections are joined and fastened with one bolt at approximately every 2.5 inches. Next, interior attach points for plumbing, galleys, and lavatories are installed for everything that the customer will attach inside their cabin. And the windows too are installed in this phase, but they'll remain covered with a protective sheeting until later. Here too, the extensive thermal and noise-reducing blankets get installed to the framework, as well as the aft cabin bulkhead entry door, which is fitted and then checked for proper operation. A few days later, the fuselage is joined to the completely sealed and pressure-tested wing in an operation you'll later see gets everyone's attention. The design of the aircraft specifically was made for the fuselage to be cut out to allow room for a wing box center section, for the ultimate in strength. Most of the 727 wing and center section is designed to carry fuel, so mismatches in this phase of assembly could create a leaky fuel tank. With the mating complete, it's time for the most serious job of securing the wing to the body. There are 4 points where tolerances are so critical, so precise, that all work in the airplane stops. No one is allowed inside the airplane while these 4 attachment pins and bushings are being inserted. All work in the vicinity is also stopped. The bushings are actually shrunk by soaking them in liquid nitrogen. When they're removed, after 30 minutes, they've attained a temperature of approximately 320 degrees below zero. So after insertion, the bushing will expand to make an exact fit. Tolerances are so precise that the bottle pin can later be installed with little effort. Now, the rest of the crew can move in to complete joining the wing to the fuselage. Here, the wing leading edge slats, wiring, control cables, and other installations like the addition of an elevator take place. On the outside, it's starting to look a lot more like an airliner. While on the bottom of the 727, Boeing engineers install and align the main landing gear and torque the attachment bolts to precise values. Soon thereafter, the airplane is lowered to the ground for the first time. Now it can be rolled forward to the next workstation, minus its radar nose dome, which will be added last. Here, the flaps are installed and testing begins. The cargo compartment is lined. Air conditioning equipment goes in, and support structure for the interior panels. And some of the cockpit panels too, before the airplane is moved to yet another building, where the various systems will be completed. Here, the airplane will take on a look familiar to passengers around the world. Our interior rapidly comes together too. Galleys, overhead storage areas, sidewalls, cabin dividers, carpeting, and passenger seats. While the passenger compartment is completed, the cockpit panels are being adjusted and tested for proper operation too. Here, the landing gear is cycled repeatedly. And the flight controls are exercised to their full extent to make sure that their movement is coordinated to the displacement of the controls in the cockpit. Specifications are first met independently, and then as an integrated system of components operating in unison. The standards are exacting, with no room for error. The last items installed are the 3 Pratt & Whitney jet engines. The only thing remaining is the acceptance of the aircraft by the customer. Amazingly, implementation to delivery of this average 727 took approximately 11 months back then. But the landing gear, as an example, was ordered 30 months in advance. And the engines about 17 months earlier. It's true that for Boeing, the 727 represented a vast jigsaw puzzle to manufacture. But for the airlines, in the end run, with over 2,000 of them made, the 727 brought jet transportation to areas of the world that had only seen propeller aircraft before it. Flying high and flying proud. That's the true Boeing 727 story. Coming soon to an airport near you.
The 727, as you've seen, was built to be tough and dependable, and also economical, too. In fact, for many of the airlines, it represented their biggest profit maker to come along in quite a long time. So in tribute to this fine aircraft, we've edited some Boeing promotional footage showing you just some of the airlines and some of the countries this great aircraft has visited throughout the years. If the 727 changed short-haul flying, this airplane, the 747 jumbo jet, forever changed the intercontinental routes. Up here in the cockpit, the first thing you notice is that it's small. That's because the cockpit section of the 747 sits directly on top of where the first-class passengers do beneath it. The 747, in its development phase, also was quite risky for Boeing. It turns out that they invested so much money in its development, they might well have gone bankrupt if it was not a commercial success.
Although the 747 would eventually be the most profitable airliner in the history of Boeing, in the beginning, the engineers didn't really know that it would end up looking like this. Close to 4 years went into the 747 design phase of the project, with numerous possible configurations for the aircraft being tested in wind tunnels. $1 million was invested in this phase of testing, where every aerodynamic parameter was measured, recorded, and equated to the final design. Before line production ever started, a pre-production 747 was subjected to fatigue testing. The actual airplane was attached to test rigs to simulate years of flying in a few weeks' time. These grueling tests were eventually carried to complete destruction to test the manufacturer's design life goals. The engine design team was also hard at work. Although Pratt & Whitney built the 747 engine, Boeing designed an engine nacelle that would admit additional air in low-speed, high-power configurations. Here, a half-scale model was successfully flown to test this concept. The JT90 engine was larger by far than anything of its day. It initially was rated for about 43,000 pounds of thrust, with today's improved versions exceeding 60,000 pounds of thrust. But as a new design, it was subjected to considerable testing by Boeing. Pratt & Whitney even went so far as to lease a B-52 from the Air Force to test it in flight. In Hartford, Connecticut, the engine replaced a pair of turbojets on the Air Force bomber and was flown through an extensive series of punishing tests. These tests confirmed the entire flight and ground conditions it could possibly be expected to encounter, and then some. The new design came through with flying colors, though, and was directly responsible for making the 747 a reality. Meanwhile, Boeing engineers and test pilots were worried about how something as big as a 747 would maneuver on the ground. To prove their theories, a test rig was built to simulate how the jet would respond to the captain as he taxied it. Since the cockpit of the new airliner was 35 feet above the ground, it was unknown if an airline pilot could maneuver it accurately. In one of the tests, it was assumed that the freighter version of the 747 would actually drive up to a loading dock. In the end, however, powered loading devices were designed and eliminated this particular requirement. Still, the rig proved conclusively that any competent airline pilot could taxi the 747. In fact, the added height of the cockpit above the ground actually made navigating around the airport and its taxiways considerably easier. Back in the plant, a full-scale test rig was completed to also test and cycle all of the aircraft's flight controls. Known as the Iron Bird, the device subjected the ailerons, rudder, and elevator to the same dynamic loads they might encounter in flight. In a separate room, a test pilot actually operated these flight controls, which were adjusted to provide him with the correct feel of this totally hydraulic-powered aircraft. He could monitor these control movements too, observing exactly how they corresponded to his actions. In addition to subjecting this leading-edge flap system to millions of cycles, the Iron Bird proved this new design would work time after time. Watch as the flat piece of aluminum sheeting is ingeniously bent by the mechanism into a curved one, providing the 747 wing with extra lift capability for takeoff and landing. Computer flight simulation was used extensively to test the 747's flying characteristics too, long before its first flight. Antiquated though by today's digital units, a highly responsive servo-controlled TV camera was engineered to be flown by the test pilot over a scaled airport runway. Viewing the takeoffs and landings from a test cockpit, the pilot operated controls that were wired to the computer, simulating the flying qualities of this new aircraft. In this playback, the height above the runway is represented in the right-hand corner. Entering ground fog at 350 feet, the approach is continued on instruments until visual contact is again established. The reality of simulation is that Boeing's test pilots could become very acquainted with the 747's handling characteristics long before setting foot in the airplane. As history-making as it was then, it is commonplace now for a pilot to obtain his or her 747 license totally in a modern simulator without ever flying the aircraft. A full-scale mock-up of the 747 came next in the pre-production process of designing this new airliner. Every system, all hydraulic lines, actuators, wire bundles, everything that would be on the real 747 is installed here to confirm proper operation and interfacing of these hundreds of thousands of components. The unique elevated cockpit of the 747 presented itself with its own engineering requirements. The design team wanted the cockpit on the second floor so the main deck would be usable for passengers or freight all the way to the tip of the nose itself. The cockpit was simplified as much as possible also. With a required crew of 2 pilots and a flight engineer, the 747 flight deck became a compact office and human engineered to be as user-friendly as possible. There was room for 2 additional jump seats for observation purposes and even room for a bunk bed to allow for crew rest periods on long flights. The pilots had most essential flight controls and switches within easy reach of where they sat. The glare shield contained all the autopilot switches, and unlike earlier aircraft that required the pilots to look down to set these items, a 747 pilot could operate them at eye level. Furthermore, the autopilot control listed a word not seen before in commercial flying: land, which meant that this autopilot was fully capable of landing the 747 automatically. Engine instruments on the pilot's center panel were larger than previous ones, with a numerical readout in addition to a pointer needle. The secret to long-range navigation, independent of ground-based navigation aids, was the INS, the Inertial Navigation System. The original 707 was converted to a navigation testbed and confirmed the theories behind using very sensitive gyroscopes to detect the slightest movement of the aircraft. Basically, all the pilot had to do was to program the unit with the exact coordinates of the airport gate at the origination and destination, and a list of waypoints or places that he wished to overfly en route. Each pilot had their own weather radar display, a steering tiller used to taxi the 747, and their own handy folding map table. The flight engineer, also referred to as the second officer, had a large panel that controlled mostly all of the major systems of the 747. Although it looks intimidating, the designers grouped the dials and switches into logical arrangements. Individual sub-panel assemblies make up these system groupings, so that everything concerning the fuel system, for instance, were found together in one area. Without a doubt, the 747 was a massive design and engineering project. To Boeing's credit, they enlisted the help of thousands of subcontractors and used their industrial experience to the maximum. To accomplish this, the aircraft was sectioned into smaller units, although small by 747 standards could also be quite large. NORAD, a division of Northrop, was assigned to build sections 42, 46, and 44. They became by far the largest contributor to the project, shipping these sections by rail to Boeing for final assembly. North American Rockwell manufactured lower fuselage areas for Boeing. These components were all manufactured to specifications of 1/1000th of an inch or less. These and any sections was valued as serious business. The cockpit and a portion of the upper first-class lounge was manufactured at the Boeing plant in Wichita, Kansas, even though they still faced the same challenges as all the non-Boeing contractors did. Fairchild Hiller became the contractor for the control surface. As with everything else in the 747, never before had sub-assemblies like these been manufactured so large and to such exacting specifications. Goodyear Aerospace shipped in the wing box assemblies, on time and on budget, in custom railroad cars manufactured especially for the purpose. as far away as Cleveland, the Cleveland Pneumatic Tool Company became the sole contractor who helped design and fabricate the massive landing gears. Their experience of over 40 years of making landing gears proved invaluable to the project. And at contractor LTV's large facility, history was made on the 747. Through the use of a cold bonding process, the world's largest pressure bulkhead was fabricated. It would be installed at the end of the passenger cabin on the 747. Putting these pieces together finally became the world's largest aeronautical jigsaw puzzle. Giant overhead cranes lifted the completed sections and transported them to the final assembly area. Without a doubt, the engineering and fabrication skills evident in these assembly sequences was state-of-the-art. Still, when it came time to connect the sections, everyone concentrated on this most critical aspect. Special jigs supported the structures and allowed for precision alignment, while special tools and work stands had no other purpose but to assure that this alignment was absolutely perfect. Even the temperature and humidity of the work area was also regulated uniformly. If one section were a few degrees hotter than the one it was being mated to, the slightly expanded metal could actually prevent a successful mating of the sections. Managers from all over the company came to see their dream become a reality. The first prototype 747 took shape within a few hours' time. Still, the tension was there. Everyone held their collective breaths. It's quite possible that an error could have been made long ago on some obscure engineer's drafting table. Still, the years of effort and dedication to the project paid off. As the world's largest airliner took shape that spring in 1968, few present could realize that the shining aluminum before them would forever change the world as they knew it. Air transportation would become affordable to the masses, and the 747 would prove to be the most successful long-range airliner in the history of the world.
It was only just a gleam in the eyes of the designers, of course, that this is what the eventual interior of the 747 would wind up looking like. Customers from around the world would really begin to appreciate the spaciousness of the aircraft. But on rollout day in 1968, few of the people had any idea that the 747 interior would look like this, because it was completely filled with test equipment.
It's the new Everett plan of the Boeing company, and it's Monday, September 30th, 1968, rollout day for the 747. The press is there, along with 1,200 invited guests from politicians to businessmen. And there's also some prettier representatives here too. Airline stewardesses, as they were called back then, representing the 26 airlines that would operate 747s worldwide. Today was really for all those who had given so much to make the 747 a reality now. The employees of Boeing and their contractors. The company had bet its financial life on this project, and the outcome was still an uncertainty. So for all those present, including the thousands of Boeing employees, today was the only chance to take a deep breath and pat each other on the back, because tomorrow it was back to work to get the 747 ready to fly. It was 10:30 sharp, and right on schedule, the sound of a small airplane was heard in the distance. It was the B&W floatplane, Boeing's first airplane ever built way back in 1916. And then, in quick succession, the 737, 727, and 707 showed the crowd their stuff.
Good morning, ladies and gentlemen. 26 months ago, as we stood amidst the forest up here at Everett and the decision was made to go forward with the 747 program, the magnitude of the task that we were faced with really looked formidable. At least they did to me. The fact that this great plane is rolling out on schedule in the very fine condition it's in is a tremendous testimonial to literally thousands of people and hundreds of companies throughout the world. And it's our intent today to pay tribute to that type of effort.
Let's see the airplane.
The hangar doors slowly open, and the Boeing 747, the world's largest airliner, is rolled majestically out for the first time. Measuring exactly 231 feet 10 inches from nose to tail, it was actually longer than the Wright brothers' first flight. And from wingtip to wingtip, it spanned an incredible 195 feet. Only when it was scaled to the crewmen underneath did the awesome size of the 747 become apparent. For here was an airliner that could carry over 500 people at a high cruise speed of over 625 miles per hour and deposit them safely over 6,000 miles away. Clearly visible on the side of the fuselage are proudly displayed the logos of all the airlines to place orders for the jumbo jet. If only the airplane knew what was going to happen next, it might choose to be rolled back into the hangar instead.
Ladies, remember what we practiced yesterday?
1, 2, 3. Well done.
Christening complete, the guests are allowed a close-up view of the outside and a look at the airplane's interior. Unfortunately, there's no fancy cabin appointments to be seen since the inside is crammed with test equipment. First flight is a few hectic months away, and final FAA certification is even further off. There's still time, though, for that one last promotional photograph. In the months that followed, every system on the airplane was checked and rechecked. The landing gear and flight controls were scrutinized and put through their cycles hundreds of times. One of the final installations in any aircraft is the compass system, and just like a small Cessna, regulations require the 747 be rotated about a central point and stopped every 10 degrees to calibrate the system. January 1969 proved to be a difficult winter for test crews. Engines had to be run and trimmed for proper operation, and for obvious reasons, it had to be done outside of the heated hangar. Finally, engineering, manufacturing, and the flight test crew approved the 747 for taxi tests. Jack Waddell was the acting captain and put the aircraft through its first series of turns. Test crews carefully watched how the landing gear and its unique steering mechanism behaved. It was uncertain exactly how they might perform at the airplane's maximum 710,000-pound gross weight. But all went well, and the testing of the 747 advanced to the next level. From here on, if something went terribly wrong, the airplane and Boeing's future were on the line. High-speed taxi tests brought the jumbo jet to 168 miles per hour, right to the verge of flight. The nose wheel was even lifted off the runway to judge the feel of the elevators, and then the takeoff aborted to test the brakes and engine reversers to their design limits. Finally, the day came, February 9, 1969, and three men walked across the cold tarmac. Jack Waddell, Brian Weigel, and Jess Wallach would fly the 747 for the first time today, if the overcast could just clear somewhat. The onlookers and well-wishers waited too, as the big jet taxis out and holds in position. A patch of blue sky appears, and they start the takeoff roll.
Along here, heading 240, 1,500 feet. Little turbulence. The old girl soaks that turbulence up very nicely.
Boeing's F-86 chase plane stays right with the 747, its pilot looking over the jumbo jet closely for any abnormalities.
Okay, turning left. Turn coordinator is working, doing its job normally, apparently, and the airplane is just excellent.
The 747 works flawlessly. As they had intended, the crew leaves the landing gear extended on this first flight and concentrate on getting the feel of this bird. The flaps are extended to 25 degrees, and some more turns are made to confirm the stability of the 747. The photo plane comes in close now, too, so the world will get to see the new Boeing on the evening news. The chase pilot sees a flap on the 747 start to vibrate when it was placed at 30 degrees by the crew, so the flaps are put back up to 25 degrees for the rest of the flight, and no other problems are noted.
One thing I've noticed throughout the whole flight, I've never seen any black smoke come out at all. You can't tell from outside if the engines are running or not.
They're clean, all right. They are on the ground as well.
With those last comments between Wydell and the chase pilot, the crew sets up for a landing back at Payne Field. The stairs are rolled up while company officials and the press anxiously await the crew.
Hi, Al. Jack, how are you?
Good, good.
Well, first things first. Remember,
Good, always, right?
Okay, Jack. Natural question is, what are your impressions?
Well, Al, I guess this sounds complacent or something, but that thing is just ridiculously easy to fly. It's just a pilot's dream.
For the test pilots, the work has just begun. The Pratt & Whitney JT9D engines remain an important item and are put through exacting procedures on almost every flight. They were a totally new design, just like the 747 itself, and were an integral part of the success of the plane. Every engine start was monitored closely. They were literally writing the book on standard procedures that airline pilots would be trained from. The big turbofans were not without their peculiarities. It was discovered that if a strong tailwind were blowing up the exhaust pipe, they were prone to overheat while they were being started. So starting procedures were devised to take this and other variables into account. All three crew members had an area of responsibility during starting, and ground crewmen became a required addition to the starting procedures too. Engine gauges confirmed the engines were idling properly, while the last fuel control was selected to its normal running position. The pilot then selected the maximum engine power setting from a computer, and a gauge displayed the result. While taxiing out, the pilot also selected the water injection system on, a then-used way of increasing power for takeoff. All that was left was to advance the throttles and watch the engines respond. On the engine, spring-loaded doors opened to provide more air at low airspeeds. With everything indicating properly, it was time to do what a test pilot likes best: fly. Most flights started out with basic maneuvering of the aircraft. The chase plane usually joined up, and both aircraft proceeded out to the officially designated flight test area to conduct the exercises of the day. To be on the safe side, it was far from populated areas. Speed brakes were checked during both slow and high-speed flight, and at varying altitudes. It was important, too, that they corresponded to the cockpit indicator. Quick turns were performed to judge and adjust, if necessary, the flying controls and their response to pilot input. On the first flight, a problem was noted in one of the 4 flaps. Consequently, as testing progressed, the indicating gauge for the flaps was designed so that each flap provided a visual indication of its relative position to the wing, making it easier for the test pilot to spot any irregularities. Because only the very tips of the wings could be seen from the cockpit, this was a necessity. The landing gear system also received the same kind of testing. Indicator lights showed the pilot the various positions of the landing gear and their doors. With the gear on the way down, it was time to slow the plane down and make the wing stall. Power back to idle, the test pilot would keep pulling back on the stick until the 747 could fly no more. The 747 proved very docile, and recovery for the test pilot was simply to release the back pressure held on the elevators and allow the plane to build up speed again. Pilots weren't the only ones aboard during testing. A few hardy ground engineers were carried to monitor and adjust the thousands of pounds of test equipment installed in the passenger cabin of the aircraft. Weight and balance tests were carried out by putting water in barrels throughout the airplane, and then pumping it forward or aft to test the plane's reaction to the change in its balance point. Onboard devices accurately measured every perimeter of the test and recorded the results on magnetic tape for later review by computers on the ground. Many stalls were performed with the tail end of the aircraft made unusually heavy, a dangerous situation, and with the load centered more forward on the plane as well. All of this data was correlated and compiled on the ground, so that everyone was confident they could exactly specify the safe range of weight and balance in which the 747 could fly, with no loss of control. Although the weight and balance testing was demanding of the crew, the testing to follow would demand the most from both crew and airplane. The minimum unstick speed tests involved dragging the tail of the 747 on the runway, so it would lift off as early as possible. It was required to prove to the FAA that the aircraft could still climb out safely after such an incident occurred. Engine failures at liftoff were tested too. With its great power, the 747 could still climb out sufficiently, with only 3 engines providing thrust. In this test, the aircraft is intentionally over-rotated just after liftoff to an exceptionally nose-high attitude. The stall warning system then activates, and the test pilot lowers the nose to the more normal attitude. Landings received a considerable amount of interest too during testing. The landing gear was videotaped to record up close its response. The wheels and brakes were tested here, along with the automatic anti-skid system. On both dry runways and wet ones, the anti-skid system would not allow any wheel to lock up, no matter how hard the pilot pushed on the brakes. Maximum braking tests proved again that the anti-skid would not allow a tire to lock up and skid, and because a skidding tire would more than likely blow out, that was something to avoid. They might smoke a bit under the circumstances, but that could be considered normal. Hard landings were also performed at various weights and airspeeds. It's comforting to know the 747 can take this kind of abuse with no ill effects. The nose cone that you see has special telemetry probes installed inside it. The most abusive test was the rejected takeoffs performed at Edwards Air Force Base in California. The airplane was loaded to the maximum weight and the takeoff run aborted just before liftoff speed. The test pilot applies full wheel brakes, but is not permitted to use reverse thrust. This is the most extreme test of the wheels and brakes, and usually results in a good number of tires exceeding thermal limits and deflating automatically. In this earlier test, which the airplane failed, the superheated brakes began to disintegrate and ignited the tires. Maintaining fire control for 5 minutes is also part of the regulations, and although the fire intensifies, no part of the aircraft's skin would burn through in that time. Still, waiting the full 5 minutes for the test pilots while the tires burned and exploded must have been the longest in their lives. It was back to the drawing board, though, for the engineers, who designed a better brake assembly because of the test. One serious accident occurred during the flight test program. As this 747 approached the runway, one landing gear was seriously damaged when it struck a concrete embankment just short of the runway. The aircraft settled on the two right engines, but the strength of the remaining landing gears was such that they did not fail, and the pilot was able to maintain directional control and keep the aircraft from veering off the runway. The flashes you see are only engine surges, as no fire was experienced. Amazingly little damage occurred to the airplane. The struck landing gear had to be replaced, and the engines needed some sheet metal work, but had this occurred at an airline, no injuries would have resulted, except to the captain's pride. Boeing spent a lot of time designing the emergency escape system for just such occasions. 10 main floor exits were provided for passengers, and an upper deck exit was also installed. The doors were double wide, but were still capable of being opened by the smallest flight attendant. An escape slide would automatically inflate, this one designed to evacuate passengers from the exit over the wing. The doors were heavy and were equipped with a special power-assisted opening device that would mechanically drive the door fully open. At this point, the automatic inflation sequence would take over and inflate the slide. Any one exit was technically capable of evacuating about 100 people in 90 seconds. This, of course, wasn't good enough for the FAA. They wanted to witness an evacuation at night and with actual people, not company employees. And so it was that Boeing put out advertisements and rounded up a typically average group of civilians. They were only told they would be involved in an experiment, and when the emergency lights came on and the evacuation order was given, the test was officially underway. Infrared film was used to record the evacuation taking place inside an actual 747 in a blacked-out hangar. The lighting you see was only provided by the airplane's interior and exterior emergency lights. The FAA representatives also secretively disabled half the doors on the airplane. The regulations required that all 509 passengers had to be evacuated through the remaining exits within 90 seconds. With official time clocks recording the results, only the FAA inspectors were left aboard when the time ran out. After certification of the 747, the Boeing test pilot's job became a bit easier. Before an airline could take delivery of their new jet, the test crews would go to work to wring it out a bit. Checks and cross-checks. This was the start of a lengthy process to determine that everything had been put together properly and was functioning correctly. Now was the time to abuse the plane a bit too, to make sure it could take the rigors of flying up to 15 hours every day at the customer's airline. Cabin pressurization systems are programmed for automatic operation, and then the manual backup system is checked too. Engines are shut down in flight and then restarted just to make sure that they too work as advertised. And then the pilot becomes a computer programmer and signals the autopilot to take control. With a few movements of his fingers, the computers take over and the airplane is under electronic guidance. The controls may still move, but they are manipulated by pure logic and not human hands. The test comes to the ultimate conclusion when autopilot alone takes the 747 in for its last landing. testing's complete now, and the owner's pilots arrive to fly their new Boeing home. In a few hours' time, the new 747 will leave the flight line at Everett for good and probably never return again. And within a couple of days, it will probably also begin revenue service on routes throughout the world. Home base may be as close as San Francisco or as far away as Singapore. The 747 will have an active career spanning well over 20 years of flying. Still, for the next few hours, with no passengers aboard, the new 747 belongs only to its pilots. Of course, they'll turn, but for now, it's theirs, and theirs alone.
Boeing may have built the 747, but it's the airlines who will tell you that it was they who operated them. Here now is my favorite video montage showing just a few of the airlines and countries that this great aircraft has served through time. Oh, stewardess.
of course, leave it to Boeing to improve things. The hangar doors opened again for another rollout ceremony in May of 1975 for the 747 SP, the special performance version of the standard 747. About 47 feet shorter in length, it carried 100 fewer passengers and was designed to provide non-stop service to cities that were up to 6,900 miles apart. It cost about $28 million in 1975 dollars versus the 747-200 series price tag of $31 million back then. It was a complicated engineering task to shorten the 747 for this project, and the aerodynamics of the new design were different enough to require a complete flight test program. Still, only 35 SPs were ever made, yet they were responsible for opening non-stop routes like New York to Tokyo to commercial aviation. It was the airlines, and not Boeing, however, that had to figure out how to keep the passengers entertained and fed during the typical 13.5-hour trip. Rollout ceremonies do tend to change just a little bit through time. The 747-400 appeared from the mist to those attending the January 1988 ceremony. And this would be the airliner that would pilot Boeing into the year 2000 and beyond. And make no mistake about it, high-tech and state-of-the-art was what the 747-400 was all about. For $120 million, airlines would get the very latest in cockpit technology, which features a required crew of just 2 pilots. Winglets were added to the wingtips and had the desired effect of decreasing fuel usage and increasing the potential range. Between the new engines and the improved aerodynamics, this 747 would get 21% better miles per gallon than the classic version did. 5 cathode ray tubes presented the pilots with the information that was previously displayed on hundreds of dials and gauges. So sophisticated are the computers that the flight engineer is hardly missed. Not only can the 747-400 diagnose a problem, it will remedy the situation if possible and prepare a full report for the mechanics as well. With advances in technology came reliability and increased performance. The gross takeoff weight was increased by 75,000 pounds to an amazing 870,000 pounds. Although it carries about the same 500 passengers as earlier 747s, it is now the world record holder for long-range routes. Boeing manufactures other airliners too. The 737 is in its 5th series of derivatives since it was first introduced in 1968. Seating up to 130 passengers, this jet has become 3 airliners in one. From a short-haul trip to the moderate and even the long-range jet routes, it's all in a day's work for a 737. And it's proven itself by providing airline service to runways not often visited by jets, all the while providing passengers with the safety and comfort they expect from a Boeing. The 757 is a totally new design, accommodating about 180 passengers. Boeing knew the 727 couldn't be manufactured forever, and by the time the 2000th one was made, the 757 was ready to take its place. Sporting an electronic cockpit, the 757 delivers the best operating costs of an airliner its size. Its big brother is the 767, a wide-body jet seating up to 245 passengers in standard configuration. What is truly amazing is that both the 767 and 757 have nearly identical cockpits. A license to fly one is good on both, a tremendous cost savings to the airline. The 767 provides the wide-body comfort passengers like for both long and short routes. The aircraft first entered service in 1982 and has seen numerous improvements since. There's even a stretched version called the 767-300 and another on the drawing board. The long-awaited Boeing 777 will be an even longer and wider version of the 767, due out in 1995. It's no wonder, then, that more people have flown in Boeings than in all other types of airliners combined.
You know, of all the airliners I've flown, the 747 is still my favorite. But as a pilot or passenger, it's easy to lose sight of the thousands of men and women at Boeing who build these fine machines. I hope we've changed the way that you'll look at a Boeing, too, the next time you see one. In closing, we edited a time-lapse view of the folks at Boeing doing what they do best, building a brand new 747-400. Thanks for watching. As for me, I've got a plane to catch.